Good morning and good evening, everyone. So till now, we completed Docker actually. We installed Docker and then we practiced Docker commands and then we created our own images through Docker files. We practiced all instructions and then we understood the difference between few important instructions like add versus copy, arg versus env, run versus cmd, command versus entry point. So all these things we understood later. We configured our RoboShop as Docker, and we used Docker Compose just to run the images as containers. And we completed the project, and then we know we understood the best practices and we implemented as well. So the best practices. So I get that question, and someone posted yesterday also. So this question is asked in the interview. So where was it? Somewhere I just read that. This is Kubernetes. This is Kubernetes types modules. Have you written Docker file in best practices? If yes, can you explain the keywords is used? Okay, so they asked what are the keywords is used and the best practices as well. So what are the best practices? Keep the image size low. Use official images. Use multi-stage builds. Don't run containers with root privilege, root access. And what else can you just write in the chat? Keep the environment separate from code. And what else? Persist the logs so that we will get it in Kubernetes. And then what else? Maintain own network instead of default. Create Docker volumes. Okay, so these are the best practices. And the final thing I wanted to tell you today here is optimize layers. Okay. So what are layers in imaging? Okay, what are layers in imaging? Before that, let us just understand the simple Docker architecture. So this may be also important interview question, but this is very simple. We already know that Docker architecture. So what is happening when you are working with Docker? For example, just see this client. Client is nothing but the Docker command. So when I'm running Docker command, this is client. And this client is interacting with Docker daemon. Docker daemon is nothing but the package we installed, Docker CE. So Docker daemon is running in your server, right? So this is the Docker daemon. Whenever we run systemctl start Docker, so that is the Docker daemon. So the command you are giving Docker is Docker client. So when I'm running Docker something, so this client is interacting with Docker daemon. For example, when I run Docker run -d -p 80:80 nginx. So what is happening? So this Docker client is asking Docker daemon to run the nginx image, and it is saying it run in detached mode, and then the ports are this one. So then Docker daemon will check whether the nginx is available in local server or not. If it is available, then it will, you can see here, it will check its images, local image like Docker images. If it is available, then it will create the container out of it and then it will respond to the client. Client is nothing but our terminal. If it is not available, it is pulling from the registry and creating the image here and creating the container. Okay, for example, let us see this. So this Docker client asked Docker daemon to run the Nginx. So it is unable to find the image locally. So it is pulling and then it kept it in local. And from this image, it created the container as per your configuration. So that is the Docker architecture. So if you got this, if you get this question, explain the Docker architecture. Docker architecture contains Docker client, which is the terminal, and Docker daemon and local images, local image registry, and then central image registry. That is nothing but hub. So when we run Docker command, so Docker daemon will check whether the image exists in local or not. If it is not exist, then it will pull the image from the registry, create the container out of it, and then respond to the client. So that is the simple Docker architecture that we already experiencing it. There is nothing difficult in that. Architecture is nothing but what's happening from the beginning to end. And I'm running this command, what is happening and what is the final response. So this is the response. Now you can see Docker container is running, right? So this is the Docker architecture you have to explain whenever you asked. And then Docker layers. This is important. Okay, so let me run few things. That is, here I will create something called layers. Docker file. Okay, so let me copy this. So do you know what is happening here? Once the Docker image is created, can we modify that image? Can someone please respond in the chat? No, we cannot modify the image. So that is the advantage. Once Docker image is created, we can't modify the image. So Docker image is immutable. Okay. So Docker image is immutable. Cannot modify the image once it is created. So that is the trust we have on the Docker. Once you create the image, you can take that image into any environment and you can run it as your application. But here, while creation of the Docker image, so let me push this. While Docker image is creating, so it is mutable actually, only with Docker. So this is layer 1, this is layer 2, this is layer 3, and this is layer 4. So Docker follows the layering approach. Now we will see what will happen. Docker build -t, and then, for example, layer :v1 dot. Now you can see first instruction, it pulled the image, okay, from Alma Linux 8. So what is happening here? First instruction pulls image, and then it will create container. It will create container out of this image. Okay. So now layer 1 container is created. Okay. And then, so inside this container, Docker is installing this instruction. Okay. So inside layer 1 container, Docker is running second instruction. Okay. Now layer 2 image is created. Okay. Once layer 2 image is created, to run layer 3, what is happening? Layer 2 container is created by Docker engine, for example. Or for example, layer 2 container is created by Docker engine, and on in layer 2 container, layer 3 instruction will run. Okay. So layer 3 instruction is nothing but this one. Okay. Now layer 3 image is created, and that is fine. So here also actually Docker is not modifying the image. If you carefully observe, first it is creating container out of the image, and inside that container, it is running the second instruction. So this is how the layering approach will work inside Docker. Okay, so explain Docker layers. So whenever, if you have 20 instructions in Docker file, every layer, it will create one intermediate container. So once this layer 2 container is created or layer 2 image is created, layer 1 container will be automatically deleted. Okay, so those are intermediate containers. So if you have 20 instructions inside Docker file, every instruction, it will create an image and intermediate container. On top of intermediate container, it will run the next instruction, create image out of it, and delete the previous container. So this is how the layers will happen inside Docker. Okay. So you can see. And these layers actually cache. So we will see what is that cache also. Yeah, here you can see. So adds Apache, and then it will create the container, and on top of it, it will install this, and then the layering approach, it will happen one by one. Okay. So if your instructions are more, then obviously your number of layers and the build time is high, right? Correct. For example, so let me do something to demonstrate this. So before this, yum install git-y, for example, and then run yum install maven-y. So I'm running these instructions. Okay, I added 2 more. Now let us see what will happen. Now it went directly to the fourth layer. Why? Because these layers are already exist. No need to create again. You can see this already in cached. So Docker is following the layering approach. Whenever you build the image, it will create the layers and it will store those layers. So that is Docker implementation. We don't know how is it happening in the background. For example, Docker login while pushing also. Just to save the memory. Imagine there are crores of images inside the Docker Hub. If Docker started creating the memory for each and every image separately, then obviously the storage is not sufficient. So that is why Docker is following the layering approach. It will store the layers instead of images. Now you will see that when I push Docker images, let me push this Docker tag layer :v1 join DevOps / layer :v1 Docker push. It is pushing the layers, one layer, second layer, third layer, fourth layer, something like. You can see this is mounted from library Alma Linux. So this layer is already exist. So that is why it is saying mounted from library Alma Linux. Remaining layers are not exist. Now if you try to push again, the layer already exists, layer already exists, layer already exists, layer already exists, layer already exists. Now if I change something here, for example, run yum install, for example, gcc-y, some package. Now I will pull, I will build it. Now you can see all the layers are already exist. So on top of these layers, Docker is giving this one. Docker is installing this or last instruction. So it will scan whenever you write Docker files, it will scan each layer. It will scan this one. Okay, this layer is already exist, and it will scan this one. These two already exist, and these three already exist. These four already exist, and these five already exist. And finally, this is not exist. So then on top of this intermediate container, it will fetch the layer. Okay, so layers you should understand the layers is like this. So this is layer 1. This is layer 2. This is layer 3. Layer 3 have the previous instructions and on top of it the extra instruction. Okay. So then till here already exists. Then it will on top of this, it will install this one. So that is what happened. Now let me push this at the time of pushing also. Sorry. I need to retag. Now at the time of pushing also, Docker engine will check for layers. You can see previous layers already exist. Now the new layer it is pushing. Okay. Now if you see Docker images, how much memory? 794 memory, 794 MB memory. Now how can you optimize these layers? So you are installing everything here. Instead of installing here, what you can do, you can, instead of creating multiple instructions, this is because multiple instructions will create multiple layers that will increase the memory as well as the build time. So instead of like this, what I can do here is I can run a single instruction. Okay, so that is and just give like this. For example, if I run like this, okay. So now this is one layer, one instruction, one layer. I am reducing the number of layers, but the functionality is same. Like layer v2. So when Docker is creating multiple layers, 20 instructions, if you can make it 10, 12 instructions, then you can save some build time. The image will be given very fast. Oh, sorry, this is Maven. It's fine. Let me make this. Jesus. Let me run once again. Git pull. So this is together one layer. Now I change something here. So it will happen from the beginning again. Okay. Now if you see Docker images, layer 1 and layer 2, you can see at least 40 MB is reduced because of optimizing the layers. So optimizing layers is also a very best practice. And then you just tell me one thing, the free where I have to keep the frequently changing instructions, at the last or at the beginning. Suppose for example, here, just for imagination, I need to push, I need to pull something from internet. Okay. So if I keep this here in the beginning, the instruction, so if I keep it in the beginning, all layers will be affected, right? So if this is changing, then all the subsequent layers will be affected. If I keep it at the end, so then till here that is same, only the last layer is going to be changed. But if you keep it here in the beginning, then layer 2 will be affected. If layer 2 will be affected, it's a chain. Layer 3, layer 4, layer 5, layer 6, everything will be affected. So you have to keep the frequently changing instructions at the end so that so this will be completely coming from cache. Right? Now, if I keep something, run echo hello world. Okay, I'm just running some instruction at the end. Now I'm pushing this. So till here already we have the layers exist. Now if you build this git pull, let us see what happens. So it is saying till here you have already available in cache, layers already exist. So I'm just running the fifth instruction. So that is very simple. Now the same instruction, if I keep it in the beginning, let us see what will happen. Now layer 2 is changed. If layer 2 is changed, then layer 3, everything will be changed automatically. Now git pull. Now you can see everything will start from beginning. Now you can see this. Only one instruction is from the cache. Second instruction, you are changing it. So the layers are already changed. Then it will start from the beginning. So the frequently changing instructions you have to keep at the end so that your build process will be very fast. So 2 points, how you optimize the layers. Club multiple instructions into one. For example, multiple run into one. Okay. And then keep frequently changing instructions at the end. Okay. So now let us see one of our application. RoboShop Docker. Let me take the cart. So what is frequently changing instruction here? These two. Obviously, our developer is keep on changing the server.js and package.js so that npm install also will be changed. So already we kept this at the end. So already we optimized the layers. Now you can see here also I optimized. Add group is one command and add user is another command. I just mixed it both. Okay. And then here you can reduce, you can just keep server.js here so that you can save one layer. Okay. Server.js. Oh, I think only it will only accept one. So to save these layers, you can create one folder like we created here in web. Create one folder. You can just keep one instruction. Just add static in this. So these are the layers. So layering is also one of the best practice. So this is all about Docker. We discussed many things. Now let us understand the disadvantages. What happens if Docker server is crashed? What happens if you suddenly get more traffic? How to balance the load? If you have multiple cart containers. Self-healing. Something is wrong inside the container, it will stop. How can you automatically make it up and run? Okay. So what about configs and secrets? Let us have these questions. If the Docker server is crashed, so what happens? Application goes down and then you lose data also. Because Docker volumes are inside the server only, not outside. If you suddenly get more traffic, what you have to do? we have to run multiple containers. How can we do this? We have to do it manually, right? We need to continuously monitor the traffic, and then we have to run another container. For example, you run another container, another instance. How can you balance? So in the load balancer, we saw that we are adding the instances. So how can you add the instances to the load balancer here? Where is your load balancer? And self-healing. If container is crashed, how can you immediately run another container? So like we have SSM parameters stored. We kept the configuration outside of the EC2 server so that EC2 is fetching. So there is no environment to store secrets and configs. Separate environment in top. So these are the disadvantages. So generally for that purpose, we need something called container orchestration. What is orchestration? Like orchestra. Let me just see. What is orchestra here? So who is this guy? So there are like thousands of persons sitting here. So they need the instructions to play the music or to play the instrument. So this guy is giving instructions to everybody sitting in front of them so that they can play the music. They can play the instruments. Like we have thousands of containers. For example, if you take very big instances, RoboShop, Amazon, Flipkart, all the project containers are running. Okay. So we need someone to give the instructions to the container based on the live traffic. Okay. So like our manager, we have thousands of like there is a manager who is handling 100%, like development team, testing team, who will give the instructions. Maybe I'm the developer, I'm working, but I need some instructions what to work on. Those instructions are coming from my manager. So our manager is distributing the work to us. Our manager is managing us for the better productivity. So if your containers are also running, so you need some orchestration tool to monitor the containers and to give instructions to the containers at runtime based on the live traffic. So that is nothing but container orchestration. So out of that, Kubernetes is a very popular tool. Docker Swarm is also there. Docker Swarm. So this is Docker native container orchestration, but that is not very popular. So it has a lot of disadvantages. Okay. So those challenges are addressed in the Kubernetes. Okay. So we no need to worry about Docker Swarm. It is nowhere, nobody is using. So you can say Kubernetes is the solution. So Kubernetes is just giving instructions, but the work should be done by containers and images only. Kubernetes only is the instruction layer. You can see still we need containers, we need images. Kubernetes will only pass the instructions and will set the environment. Now Docker run, creating container out of image. So image is a physical file. Container is running instance of image with some configuration, right? So even you run the orchestration, you need the image. You must need image. So I'm just separating this container. I'm just removing. I'm not giving responsibility for Docker to run the containers. I'm giving responsibility. We give Kubernetes to take charge of running the images as orchestrated. So this is same. Like you will write Docker file, you will create the Docker images, then you will keep it. So we will restrict Docker only till the management of images. We don't ask Docker to run the containers out of the images. Instead of that, instead of relying on Docker, we rely on Kubernetes for the runtime part. So there are two parts: image creation and then running the image. So till now we used Docker to run the images. We gave the responsibility to Docker, but Docker is not having all these features. So we are moving to Kubernetes to run those images as containers. Okay. So any doubts still here, you can raise your hand. Any doubts, any questions? The Docker containers was originally not designed for the scalable environment. Okay, so they originally concentrated on images, and then they came up with Docker Swarm, but that is clearly also not scalable to the current environment. So we are going to have Kubernetes, and in Kubernetes we can see better networking also. Better networking. The advantages of Kubernetes over Docker Swarm is, I get this question, but these guys, they are just simply asking the question for internet purpose from the internet interviews. They will see the questions from internet and they will ask some dummy questions like this, because we are not even using Docker Swarm. How can we tell Docker Swarm versus Kubernetes? But if they ask, networking and storage solutions are better in Kubernetes. You can refer as K8. Okay. So you can say we are not using Docker Swarm at all. I don't know what is Docker Swarm, but still I can say Kubernetes has better. So I trust Kubernetes has better solutions in networking and storage. And every cloud is offering Kubernetes as a solution. Not every cloud is not offering Docker Swarm. Every cloud is offering Kubernetes as a service. So it is very easy to implement Kubernetes than Docker Swarm. Okay. Yes, Santosh Avula.
Yeah, hi Shiva. Good morning.
Good morning.
Yeah, Shiva, how to mapping the DNS address to in a Docker? How to DNS address or mapping in Docker? Docker is running as a containers.
You're not mapping any DNS. You can map with the Docker host IP address.
Okay, suppose you have to www. Your any application is calling to, right? Your end user is.
We have Docker Nginx is running here, right? It is
Yeah.
on already port number 80. You give this IP address in your DNS, then you will get it.
Okay.
Okay.
Yeah.
So now let us install Kubernetes. Generally, Kubernetes is a cluster platform as a service in any clustering solution, not only Kubernetes, anywhere. So there is a master like Jenkins also, and there is worker nodes. So master only gives instructions. Workers, they will do the work. Right? So that's how our daily life master and worker scenario also. Okay. So in rare cases, master also can do. If you don't have workers, generally we don't have any worker in our homes or in our agriculture fields, obviously we have to work ourselves. So if we don't have workers, master has to do everything. So this is up to something like a small house you can manage yourself. If you have very big building, Obviously you cannot do everything. You have to employ few workers. Okay. So that is same here. If you have very, very small bare minimum project, you can do everything in a single server. If you have a very big project, then obviously you have to do master and worker. So first let us see this, a single instance where we install everything. Okay, master components as well as worker components, that is called Minikube. And then from next week, we can install our Kubernetes cluster. Okay, first let's go with the Terraform AWS Minikube. Okay, so Minikube is nothing but in a single server, everything is installed. But that's not a production grade. It is just to learning purpose of Kubernetes. Terraform AWS Minikube, this one. So this guy wrote some module to install Kubernetes in a single server. Okay, so for that purpose, you should have existing VPC and public subnet. If you don't have your VPC subnet, you can use this configuration. Okay, so the condition here, he needs subnet ID and he needs the image ID also. He's using CentOS 7. If you don't give this, it will automatically be considered as CentOS 7. So anyhow, let us create our Terraform AWS Minikube. And because creating the cluster will take at least 15 minutes. Instead of that, just writing Terraform AWS Minikube. Okay, so we should need some provider. Provider dot tf, just calling it as Minikube, and then Minikube dot tf. Just copying this. So you should have some AWS region is US East 1, and just keeping your name as RoboShop. T3.medium. Let us use T3, the latest generation. And you need some public key. So it is expecting some public key. So let me create some public key here. Public and private key. Okay. Let me have some keys, Terraform pub.terraform. So you create any public key and private key, okay, in your somewhere, and then you have to give your public key here. So by default, Terraform dot pub. Okay, so this means this tilde symbol means my home directory. Now, okay, so this is my home directory already. So I have terraform.pub. So just to want to, you may be wherever. So you may be somewhere in your git bash, but if you just enter cd, you will be by default taken to the home directory. This is your home directory. Okay. So this tilt means home directory. So you should have this name. Just change to your name, terraform.pub. Thank you. So you can keep anything. The name is your wish. And AWS subnet ID. Let me take the public VPC we already have. The default VPC, right? We already have default VPC. And inside the default VPC, we have the subnets already. So let me take one subnet. Usually agent one. Let me take this one. You can take anything, and you have to just check it is connected to the internet gateway. Okay, I'm just taking this subnet ID, public subnet. Any public subnet in any VPC. I am using default VPC here. Okay. And AMI ID I'm not giving because he will consider by default CentOS. Hosted zone, you can give your domain. So that is join DevOps.online here. So you can give your own. And then okay, that's it. So you should get your Minikube running. So let us run this. Terraform AWS Minikube. Terraform init. I don't have Terraform user. I delete it. So generally, frequently delete your users and create new users. Okay. Terraform. Just giving administrator access for simplicity. Create user. Okay, just stopping the screen for a minute until I configure this AWS configure in my laptop. Setting the access key and then secret key, region, section. Okay, it's done. Terraform init. Okay, and then Terraform plan. Terraform apply R2 R2. So he's creating 12 resources through his module. Okay, he's creating some key pair, Route 53 record, and security group, lot of things. We don't really need to understand what he is creating. If you are interested, you can just go through that. Okay, so this will launch an instance, and inside that it will happen. Will install the all Kubernetes related components that we will understand at the end. Kubernetes architecture, we no need to understand at the beginning. Like we just understood Docker architecture, that was very simple. Once you practice that, then you can understand the architecture. But a lot of guys, how they are doing mistakes is they will try to understand the architecture first. But without knowing anything, how can you understand the architecture? So let's practice Kubernetes resources. What is Kubernetes? How can you configure? And finally, once you get the knowledge, then you can understand Kubernetes architecture better. So this is the mistake generally we find in our textbooks. So they will, for example, Java, they will tell you who invented Java, what is the Java architecture, Java features, Java memory. And once they explain everything, the theory part, they will go to the practical part. So we will lose ourselves while learning the theory and architecture because we don't know anything. We just need to remember. But the practical thing is first, and then later you can go in deep. Okay. So here, this guy is running some instance and he is configuring. So it like user through user data, it is going on. This one, RoboShop, this is going on. Now let us just discuss how we are going to practice this. So we have two parts. One is building the image and running the Kubernetes. To build the image, obviously we need Docker environment. So how I'm going to do here is, so this is our laptop. So VS Code, VS Code, we will keep it as an IDE. So this VS Code is generally to write Docker files as well as manifest files. Manifest files is for Kubernetes based on YAML. So we know YAML very well. So you'll write this Docker file and manifest, and you will have GitHub. So you push to GitHub, and then you will have one workstation like Docker. Docker workstation. So you will pull and then you will build here. Build images. Okay. And once you build the images, you will push to Docker Hub. You push to Docker Hub. And you will have your Kubernetes cluster. So this Kubernetes cluster will pull the images generally. Build images and then pull manifest files. And you will have generally kubectl is the command line to connect with kubectl. So this kubectl generally push the manifest files to the Kubernetes. Okay. So kubectl is the command line, so that can connect to the Kubernetes cluster. We will install it in Docker workstation. It will push the manifest. Okay. And K8 cluster will pull the images from Docker Hub and it will run the, generally we call them as pods. So this is what we are going to do. Okay. In our laptop, we will write Docker files, manifest files, we'll push to GitHub, and then we will pull in Docker workstation where we will build the image, push to the Docker Hub, and then we will pull manifest files. And from here, we have kubectl command installed. So kubectl will push the manifest. So this workflow, let us see that. So I have this. Now this is key based, not our CentOS 8 practice. This has the key. Let me take the putty. Just saving the session as Minikube. Okay. And connection username is CentOS and authentication. I need to select Terraform.pem, but generally you should export as Terraform.ppk. So putty gen generally putty gen. So this will convert the PEM file into PPK, putty private key. So that is Terraform.pem will and then Terraform. Okay. Save. So now I'm browsing that Terraform.ppk and I have given the CentOS, the session name, then save it. Now loading. You have to give your IP address. Load, give IP address and then open. accept. That's it. So now I will open this in Super Putty. Just refresh. Importing it. So now it's not reflected. Let me close and come back. Super Putty. Now I have my mini cube. Just give this Photoshop. Okay. So when the mini cube is successfully installed, you can see there is a cube config created. Okay. So generally, when you have cube config, you need to create a directory .cube here in your home folder and just copy this cube config into .cube as config. Okay. So now kubectl get nodes. So you have your node running. Okay, but this is the single node master, single node Kubernetes cluster. So generally we don't connect directly here. So we will install this kubectl in our workstation and from there we will connect. Okay, so just I need one more workstation. You can see this here. I need one workstation and one cluster. So cluster is already created. Let us just create the workstation. Maybe for 1 or 2 sessions only, I will use this. Okay. Later we will move to the actual cluster. Workstation.tf. I want to create a EC2 instance. Terraform AWS EC2. Take any module. Okay, this is workstation and it can be t2.micro. It is enough. Key name don't need. We'll just give our AMI. So that is our CentOS AMI ID. CentOS 8. This is CentOS DevOps practice. CentOS 8. And monitoring is not required. Security group. So let me create one allow all security group. Generally, it is already existed here. Allow all is already exist, right? So let me create anyhow another one. Terraform AWS security group. This. Just naming this as allow all minikube. Allow all traffic for minikube. Okay, so VPC is our default VPC. I'll just get this. If it is default VPC, actually, we no need to give, I think. This will be automatically considered. So all traffic from port is 0 to port is 0, I think. Yeah, protocol, everything, and CIDR block, same as like this. I don't need this one. IPv6. Okay, I'm just creating one allow all traffic for Minikube, and I'll consider this one here. AWS security group dot allow TLS dot is the output name. ID. Subnet is again this one. Okay. Yeah, that's it. So I'm creating workstation, and I can give our user data. User data equal to file of docker.sh. So we have our docker.sh, right? So by default, it will be installed because we need Docker. So this one, just giving docker.sh. It will get the Docker installed automatically. Yeah, that's it. Now let us run Terraform plan. Terraform init. Terraform plan. Terraform apply. So this will create the instance, attach the security group. Okay, instance is getting created. may remove stop. The Docker is still getting installed. Then I need to install kubectl to connect to the Kubernetes cluster. So that is install kubectl on CentOS 8. So this is a simple thing. Let the Docker install. Okay, it is done. Docker please exit and log in. Docker PS. Okay. Now I need to install kubectl. So this is just follow this. Kubectl is installed already. Okay. So installation is very simple. I'll just make it as part of Docker script. So now I want this kube config. So this is the authentication information actually kube config. This got stuck. Okay, so this is the configuration information generally to connect to our cluster. So this is the full authentication information. So you need this generally. You can see here you have all the details available. Your record and then your cluster certificate, everything. So this is the authentication information generally. So you need this anywhere to connect to the Kubernetes cluster. Now what I do here, make directory .kube and then cd.kube vim config. Why I'm creating like this? Because kubectl by default will read from this directory. It expects .kube and inside that config file. Okay, kubectl get nodes. Now you can see from the workstation you are able to connect to the Kubernetes cluster. Okay, that's it. So I'll just write 1 or 2 resources and then we'll end up today's session. So everything is called resource in Kubernetes. So I'm going to write K8 resources. I need to create the repository. K8 resources public. So as I said, we'll be writing manifest, Kubernetes manifest files, uploading to the GitHub, pulling from to the workstation, and from here we can push. So basically manifest files you can push from anywhere. You can push from your laptop also. Okay. But at least we need Docker workstation to build the image. So K8 resources, K8 resources, and then git init, git remote add origin. This one. Git add K8 resources. Okay. Oh, it has nothing. Okay. So let me write something. So first resource you learn inside Kubernetes is nothing but namespace. What is namespace? Isolated project space. Like what is VPC? Virtual private cloud. So every project will have one VPC. Inside that VPC, you will create the resources. Similarly, you will have namespace in Kubernetes that is isolated, just a space, that's it. And then inside this, you will create your Kubernetes resources, right? So if you don't give that namespace, if you don't create, it will have one default namespace. Now let us see this. kubectl is the command line, get namespaces. So we have something called default namespace. So remaining namespaces are used by Kubernetes cluster. We'll understand later. Okay, if you don't have any namespace, by default, Kubernetes uses default namespace. But let me create our own namespace. That is 01 namespace dot yaml. Okay. So how you get this file or folder? 501 dot names, so 01 hyphen namespace dot yaml. Okay, so you will always refer Kubernetes documentation, Kubernetes namespace. Okay, you can see isolation of your project resources within the cluster. So there will be this is there. So the Kubernetes syntax is always this one. What is the API version? Mostly it is V1 and it may have something else. Kind and metadata, the information, and this is RoboShop, for example. Okay, so this syntax is going to be same for any kind of resources. You will don't worry about what is resource, how can we create everything, you will get it slowly. Okay, so this one kind, the name of the resource and the type of the resource is namespace, API version, and name. This is RoboShop. That's it. Now I want to push this. and I am pulling here inside my workstation. Git clone cdk resources. How can you apply the resources? kubectl create -f file name, which file you want to apply, namespace.aml. So now kubectl command will connect to the cluster and it will create the namespace. You can see namespace got created. Just kubectl get namespaces. You can see our RoboShop is created. Now if you apply again, generally you get an error. RoboShop already exists because you are trying to create. So there are two commands, create and apply. When resource not exist, you can use this. If resource exists, you will get error. But there is apply. So when resource not exist, it will create. If exist, it will just update. Update or does nothing. So it is always safe to use apply instead of create. So now going forward, I will use kubectl apply -f file name. So this is the one actually. Since we already gave that create once again, we got the error. No problem. That is warning only. Okay. So now if you want to delete kubectl delete -f0. Okay, namespace is deleted. Just two commands. Kubectl apply -f, which file you want to apply. Kubectl delete, which file you want to delete. Okay. So yeah, so we can stop till here today. So we install the cluster. So this weekend you complete the entire Docker and then Kubernetes cluster installation. And next resource we discuss about is pods. Okay. So this AML is going to be the same. There is now nothing to worry. We already know about AML very well, and we can easily copy the content from Kubernetes documentation and then we can create it. Okay. So I'll push this Terraform AWS Minikube also. Just while creating, you replace with your own subnets, okay? And then replace with your domain. Okay. Replace with your public key name and path. Okay. So any questions? Yes, Sri Lakshmi Reddy Taripatri. You can speak.
Sorry, sir, by mistake I have missed.
Oh, okay. Sai Arun Yadav.
Yeah, sorry, sir. It has happened by mistake.
Yeah, it's okay. Mr.
Okay, sir. Sorry for that.
Any other questions from anyone? Manohar Reddy,
Good morning, Shiva.
good morning.
Shiva, in manifesto file, you mentioned the first line app version.
Okay,
So, could you explain that what exactly it is?
so there are here in Kubernetes resources, they are categorized. A few resources, they are in app/v1 and few resources, they are in different versions, just categorizing of it.
Okay, so it's a mandatory keyword we have to use.
Yes, it is mandatory. kubectl API resources. Now you can see there are a lot of resources and they are categorized. Mostly they are in v1 or apps:v1 and few resources they are in different.
Oh, okay.
Okay, so storages, it is in some resources are related to storage, so they are here.
So this keyword we have to use.
Yes, just it is the keyword.
Oh,
Just categorize instead of keeping all the resources under one category, so they created different categories for maintenance purpose.
okay. Thanks.
Okay, and from AWS Minikube, I'm going to .qt node is important. So you can refer this repository and make sure you replace with your subnet ID server. There is one question in the chat, Docker container lifecycle. There is no Docker container lifecycle at all. It's a stupid question. Lifecycle is nothing but from the creation, it will delete. So you know how to create the container. We practice Docker create, Docker run, Docker stop, and then Docker delete, Docker rm-f. So this kind of questions, they don't know what to ask. They will just get it from internet. What is lifecycle? Obviously from the birth to death, right? You can see Docker create, Docker start, Docker run, Docker pass, Docker stop, and then finally Docker remove. So that's it. So when you find these kind of questions, you can just simply search in internet. There is you don't need to wait for me to explain everything. So obviously I cannot spoon feed everything to you guys. So you have to just practice the Google search also sometimes. Okay. Yeah, that's all from my side. No questions, we can end the session. Have a nice weekend. See you on Monday.